Hello there, can you hear me? I do have voice. I was just gonna do a stream today, going through some components for a Bluetooth board. Before I do that, I was just gonna finish off doing a presentation for exercise 1.41. Only when I speak, yeah, because I just started the stream. I don't really stream that often as well, so yeah, it's gonna be a bit amateurish, isn't it? How are you doing anyway? This equation or this exercise is calculating an RC filter with a gain of 50 at DC, and then basically it stops attenuating as the frequency goes up. So obviously you got the response on this slide over here. Hopefully you can see that. I think doing the circuit equation is quite easy, or doing the circuit itself is quite easy, because you can see that, you know, this is a combination of two different things. So you've got a high pass filter, obviously, so the attenuation at high frequencies is quite low, or is very low, and then you've got a gain of 50% at DC, so the, you know, only resistors will help at DC, so capacitors will be basically very high impedance, so they won't be doing much. So you can see it's a combination of a high pass filter with a potential divider. So the equation for this, calculating the resistors, you want the load to be a lot higher than the source resistance and a lot lower the load resistance. So as soon as I finish this off, I'm going to do some component calculations and schematic capture for a Bluetooth board using STM32 WB55. I'm not sure if I'll be able to finish this off. I might do that tonight when I'm not on stream. Yeah, I'll just leave this here for now. And then go back to basically doing this hardware design that I'm working on with a Bluetooth board using STM32W5. So what I'm going to do now, basically make a new project for this. File, new project. I do have an application in mind for this, and there are a number of different things that I need. The first one is a Bluetooth board or Bluetooth capable microcontroller and a gyroscope, an IMU, I guess, chip. So I found some parts that I think will work for me. So I've got, obviously on the screen now, you've got the bill of materials. So basically this part here, which I think is quite common. And then I've got the STM processor as well. I've not used STM processors. I've mainly worked with microchip processors in the past. So we'll see how that goes. Should be okay. Should be a learning experience for me as well, so that's fine. So first thing first, let's make our schematic on this. I'm gonna go in here and do the page settings. So set today's date, revision. Let's call that rev dash or rev a for so let's see if the microcontroller is actually available in the library itself, because if it's not, then we'll have to create it. That reminds me, I need to update the title for this, because that is some old title, because I used to do a little bit of streaming back in when I started this. I've not really done streaming for a while. So just go to my bill of materials that I was working on last night. So STM32 WB55CG, got CGU6 there. That's the right package. Yeah, this is the right part, so that should be okay. Put that down in the somewhere in the middle. And for grid, I want to go for 2.54. And another thing I'll need to do is basically make a project for STM Cube as well, so that I can do all the pinouts and everything like that. Now I've got the datasheet open for this part, so hopefully you can see that on the right hand side. I'll try to make this as easy to read as possible, but obviously it's quite difficult when you only have one screen. Now this is not the right package. We have a micro QFPN 48. It's not that one. Now there should be a diagram here that tells you what resistors that you should connect for the power lines. Also say all packages except this one there. So that would be all right. So let's quickly have a look at this and make sure we do that. So I'm gonna close this so we get a bit more space on the window. And to place a new part, you can press the A button on your keyboard. And obviously, if you have any questions, just let me know. I know there's not many viewers around, but that's fine. So I need some capacitors first of all. You can see all the power pins are around here. So that's fine. And it's typically for VDD pins, you need one capacitor per VDD pins. I've got 1, 2, 3 at least over here. So I'm going to put down 300 nanofarad capacitors, and then the recommended is one 4.7 microfarad capacitor. So let's do that now. It's not, might not want to use that, so I might just change that to 4 micro 7. So we don't have a full stop in there. Okay, so 3 of these. Move that out of the way. So just connect these up. The bottom of these capacitors obviously go to ground. So you can either press the A button on the keyboard again, find the ground symbol, and place that down somewhere around here. If you have any suggestions for me in terms of chip antennas, was one of the Bluetooth chip antennas, one of the components I've been looking for. That would be great. Something that's easy to source, obviously. I reckon I can move this down somewhere a little bit. Obviously, I got the reset pin as well, so let's leave that as is for now. So that's VDD, all three of them connected, plus the 4.7 microfarad capacitor as recommended over here. And then on the VDDA pin, we've got a 10 nanofarad and a 1 microfarad capacitor. Now I'm not going to have anything analog on this board at all, so I don't need it to be particularly low noise or anything like that. So what I'm going to do is just connect this up here as well. So we've got that to ground and connect this pin up to here. And then we have VDD RF pin. So that's going to be for the RF section of this microcontroller. So the RF pin, we've got a 100 nanofarad capacitor and a 100 picofarad capacitor. I think we probably don't need the 100 picofarad capacitor, but I'm going to put it in anyway, and we can test when we do the actual hardware for this, see if it's actually required or if the board works fine without it. So what I will need to do right now is change that to 100 picofarads, obviously ground that. Might need to move this out because you can see there's a few more pins in here that I need to connect up. VDD USB is also 100 nanofarads, so I'll just copy one of these components, put it down here. Go and copy the ground symbol because I need this connected to ground as well. Now the switch mode power supply, this is an interesting one. I've not seen this before on a microcontroller. Well, I've not worked with STMs before, but you see you've got the ground, or it's got its own switch mode regulator. Obviously it needs a 4.7 microfarad capacitor, an inductor, which there's a note there, so the inductor value depends on the frequency. So we'll need to check out table 6 as it says on the note down here. And basically VDD SMPS, so that's the 4.7 microfarad one there. So what I'm going to do is VDD RF, that also goes to 3v3. Obviously I've not got the 3v3 node in here at the moment, so I'm just going to go find that. So 3.3. And then I need a 4.7 microfarad capacitor. So just grab one of these, put that down here. I think it might be worth taking this on this side and bringing this component, if I can select it, to this side. The last pin I need to connect is the VBAT pin. So you can see I need, this is for an external battery. I think it's for RTCC functionality. So I'm just going to connect that up to this side over here. I think that's all my capacitors for the power supply lines sorted out. I am going to put the switch mode power supply on a slightly different. Well, I'm going to connect these up to ground first of all, so let's do that. Go into here and copy this part. So that's the ground connected. You can see I've got an inductor and a 4.7 microfarad capacitor over here as well. Now this schematic symbol is a little bit messy, but that should be okay. So if I put in this, I know I'm going to put in a crystal over here. So let's get that crystal first. So I've got the crystal. What I need to do over here is, so this crystal itself will have some frequency that I'll need to find a crystal for. I think for this is 32 megahertz. Well, I'll do some research on that. There is a application note that we can use. So if I go back to design notes, application notes, STM32 RF hardware design. On here we had some recommendations for the crystal, so you can see it's a 32 megahertz crystal. Strangely, they don't have any load capacitance. Maybe it's internal to the microcontroller. And then obviously you got the second crystal on PC14 and PC15, so that's these two pins over here. Okay, so no load capacitors on here, but I think I'll just add them in just in case. So net labels first of all. So make that a little bit smaller, I think. That is out. And we see that this schematic is going to look a little bit messy because just the way this symbol is, but well, should be all right. Move this a little bit down. Actually, looking at this, I've got the RF on this side as well. I really don't like that. Let's see if I can sort it out. So edit, mirrored, nope, not angled, mirror around x-axis. That was obviously wrong. So edit, mirror around y-axis. And then I got RF1 on this side. So I'd like to basically just keep my outputs on this side and inputs on this side. But that means that a lot of this thing I need to basically redo, but that's okay. Just do these tracks for now and connect this up. I know this needs to connect down here. And so add in some load capacitors for this. The value for this I'll leave open and set them as do not fit. Obviously this is going to be quite messy. And maybe I should just design my own symbol for this processor. So to do that, obviously I can set the do not populate flag, which tells, and I want to set it as, oh no, we can add in, we should be able to do that on the bill of materials so that it's automatically generated. And it tells the assembler that we're not putting anything there. So now the next thing I want to do, move this, and originally obviously that started its life on the other side. So again, just looking at this, looking at the data sheet, basically following the recommended layout for the power supply decoupling. Move that out of the way, move that this side. And the last thing I want to do is remove this component. I like to put my bulk capacitors on the other side of where the pins are. So this was connected to VPAT, VGDA, and all the VDD pins. So that's all of them. The RF input, which is VDD-RF, has a 100 nanofarad and a 100 picofarad capacitor. So let's just fix the ground first before I forget. So VDD-RF had the 100 picofarad capacitor. VDD SMPS, so that's the switch mode power supply decoupling capacitor, had the 4.7 microfarad, and VDD USB had the 100 nanofarad capacitor. We will be using the USB features on this. Okay, let me just move this to this side over here. Well, that does look a little bit messy. I think it'd be better if we have this component on this side. I'll fix that later. for now, I just want to try and basically finish my bill of materials for one thing, and do the STM project as well. So that's an STM Cube IDE. And like I mentioned, obviously I've got all of these parts that I've already found. There are quite a few parts that I still need to look for. So I'll see what's available on here. One of the main ones is trying to find a battery charger circuit. I know there's the TP4056, but then that needs a few external components as well, which I don't want to use. Let's see if I can find this 3v3 power supply. So that is a MIC 5205 3.3 Y5M, so that's fine. What I'll do, I'll put that somewhere around here for the time being. I might need to move this a little bit down. So I've got the RF that I still need to get into this part here. Still got this. It's just gonna look messy, but it is what it is. I've got my USB-C connector. I'll see if that's available on the parts library. So USB. So there's quite a few over here. So you've got USB-C 14 pin. I know it's a 16 pin port that I have, so it's going to be this one. So let's take that and put that down here somewhere for the time being. Got the V-bus pin, which is going to be the input on this. Just loading up the data sheet for MIC 5205. Let's see what the enable pin is. So enable, forcing enable high enables the regulator. So we just want to connect it straight up to this voltage line here. I do want to add some protection IC on this. So I know there's USB L6, C6. Let's just bring it this side so you can actually see. What's the difference between these two? I want this one. It's the package. So I think this is the package that I need or want to use. And so that's V-bus. I'm gonna add a label on there. So +5. We've got +5 volts on there. We can put a power plug on there later as well. With USB-C, I think you connect up the ground and the shield. So let's do that now. Then you've got the data minus and data plus. Obviously, they're going to be connected together. And then you've got the CC pins. Again, that's going to look a little bit messy. I need to check what to do with the SBU pins. Hopefully they can be not connected. Let's have a quick. So the CC pins are for asking for current and power delivery. So that's okay. Just need to find the functionality of SBU 1 and 2. I think because we're going to be device mode only on this, I don't think we need to connect them up. So I'm just going to put a no connect flag on this so that we don't get an issue. I'll do a little bit more research on that afterwards. So that no collect flag is over here, and this is only so that when you do an ERC design rule check or electrical rule check, it doesn't flag it as an issue. So let me move that in a little bit. And for CC1 and CC2 pins, I just want to connect them up to 5K1 resistors, or maybe 5K11, I think is the common values. So just get device, again pressing the A key, and they need to connect to ground. So what I can do is move this a little bit forward. I'm not sure if it's 5K1 or 5K11. So let's have a quick look at E96 series. So that's the E96 series. Got the 5, so it's 5.11 on E96. So 5K11. And that connects to ground. Now for the net labels, I'm going to put USB D minus. So that's D minus. USB B plus. And then I need to do something on this side as well. So let's just bring it out for the time being and add the net labels. So this is filtered or protected, as it were. D plus. So I've got the 5-volt flag on this, so that'll be fine. So that'll just stay as it is. I think I might be able to move this into where it was. This still looks a little bit messy. I wish the CC connections were down here on this symbol, but they're not. So I'm not going to redesign that component just for this. These USB pins will need to connect to some pins on here, so I might as well start loading up my project. So desktop. So STM cube. Is it loading? What's happening? Ah, there we go. File, new project. I'm gonna save it in some location that's good for me. I guess the kind of the project folder I'm using for my YouTube videos. How are you guys anyway? Having a good bank holiday weekend? Oh, if you're in UK. Obviously, if you're not in UK, you probably won't have that. So just look for my processor. 55 CG U6. So that's that one there. Start project. And the first thing I want to do is just check where the USB connections are going. So connectivity, USB, device. So that's PA12 and PA11, as you can see on here. And then they're not, can't change them to be anywhere else. So just looking at that, obviously that's fine. So USB, DP, and DM. Going back to my schematic, so PA, I've forgotten already, maybe too much wine. So DP is on PA12, so that's positive. PA12, so that's down here. and the other one, which is PA11. So that's DM. So that's that one. So that's how a USB connection's done. Normally there's a USB detect as well. So just the device, I'll just make sure the setting. So it is a device, that's fine. And the process I've used in the past, there's always a USB detect. I'll do a little bit of reading on that. Might need to find it like a STM technical note or application note for USB. Just make sure I've got the hardware configuration right. But for the time being, that's okay. Let's go back to this component. So this is our regulator. Look, MIC 5205. And you can see that doesn't need any input capacitor. But what I'm going to do is add one anyway. So the minimum value I think is 1 microfarad if you're not using the bypass. But because I want to try to minimize the number of different components and, you know, kind of rationalize the bill of materials, I'm going to basically connect this up to 4.7 microfarad capacitors. Now this is going to get very close to the USB spec for capacitance. So let me add the USB-C line net labels on this before I move on. USB-C C1. USB-C C2. So we've got the D- and D+. Got the non-connects up here. We've got the crystal. So what I'm going to do... No worries. Is it Niguan? Sorry if I'm butchering your name. So set up the crystal first. So that's in system, I think. No. Got the high-speed external crystal. So that is on pins, the ones you don't see down here. So 25, 24, and 25. Going back to my schematic, they should be down here. So 24 and 25. So 24 is out. Yep, so that matches up. That symbol's all right. And then I want the low speed external crystal as well. So that's on PC 14 and 15. So again, basically just going to copy this symbol. Like I said before, I think this is going to get quite messy. I'm going to basically put down some values in here as TBD because I've not decided on a crystal yet for this. That was a bad choice. Let's do that up here. So we've got PC 14 is oscillator in. Now this is going to be, never remember that frequency. So if you go to the clock configuration, press no there for the time being, is this frequency here. So 32.768. So PC14 was, go back to my pin configuration, file, save project as, basically I want to save it in my KiCAD tutorial Bluetooth board, make a new folder, STM project. So pin 14 with oscillator in. Yep, that's fine. And that was out. I think the problem I'm going to have here is trying to connect up the RF components. But we'll get to that. We can move things around when we need to. So for that, I'm going to try and follow the application note as much as possible. Got our two crystals. This SMPS, let's go back to the data sheet for this part, for the microcontroller. And you can see on the data sheet, you've got an inductor, which is connected to this point over here. So let's bring in an inductor first. So that's add a component, press the L key. I'll just put it here for now. I know I've got this reset pin that I need to manage as well. So yeah, this symbol is not the best. I should have done my own symbol really. Let me just take this off here. So we've got the inductor. I'm gonna put this side by side with this. And then you have a capacitor, so 4.7 microfarad capacitor. So I'm gonna copy this one here. And basically that connects up to SMPS and then so FB, so that's this one, so the middle of this. So this goes back to here, if I'm reading that correctly. And I've got one viewer right now. Have you used a what's it called, a Bluetooth chip antenna before? Been trying to look for some part numbers. If you have any, that'll be fantastic. I know I've got one chip antenna, but just want to make sure it works with this. I'll see if there's any recommendations in the application note, obviously. So that's let me label that up. So that is VLXS SMPS. I don't know which pin I'm doing. So that is SMPS. That goes down here. Might need to make that a little bit smaller. Okay, I mean, that works for me. I do like my things to be neat. But this symbol really isn't helping with that. I know I've complained about the symbol a few times now. So that inductor goes back to VF. I think I want to change these labels around. So SMPS, VFB, and SMPS. I'm going to call this VLX. Just because I want them to start off with the same name. Just like what I've done here with USB. So they start off with the same name. And it'll be easier to track when I do the PCB design. Now the pin 31, so that's the feedback connection. That goes back to a 4.7 microfarad capacitor to ground. So what I'm going to do is just copy this one, put it down here somewhere, copy the ground symbol, and that I'm really not happy with that at all. Let's see if I can move this down a little bit. There we go. That's better. It's not as bad as it was before. Anyway, I've got 3 viewers. Do you guys mainly watch the Art of Electronics? Do you find that useful? No, I still enjoy making the series, and I'm working on the next question. So exercise 1.41. Let me know in the chat if you can hear me as well. I'm sure the audio is fine. Got inductor here. We need to go to table 6 to find out what the value of that inductor is going to be. I mean, it tells you the 4.7 microfarad capacitor straight away. And then you've got this VDD SMPS pin connected to 4.7 microfarads. So I'll just make sure that is going to the right component. So yep, 4.7 microfarad on this side as well. So got the inductor there. Let's go to table 6 now to find its value. So L1 for 8 megahertz. I'm not sure which frequency that is referring to. An extra 10 nanohenry inductor in series with L1 is needed to improve receiver performance. Okay, so we need another one. It doesn't show where that is. Let's quickly have a look at the application note. So that's this one here. Find the, there we go, that's it. Now this symbol is a lot better. But yeah, you got a 10 nanohenry inductor first. And then you've got a 10 microhenry inductor afterwards. And a 4.7 microfarad capacitor. So I've VDD SMPS. I've not put a 100 nanofarad capacitor on this line, but maybe I should. As the reference design or the hardware application note has a recommendation for it. So what I'm going to do is add a 100 microfarad capacitor over here. And that is connected to this node. Yep, that should be all right. So that's the RF. So RF, you got the 100 picofarads and the 100 nanofarads. And the SMPS, so switch mode power supply, we've got a 4.7 microfarad and a 100 nanofarad. So that's fine. I've added the labels in, so the labels are going to be okay as well. Now the RF section, we have a matching network, as you can see on the screen now. So you have a 0.8 picofarad capacitor and a 0.3 picofarad capacitor with an inductor in between. Now what I need to do is take this RF section on the outside. So let's try to do that. So I'm going to move this up somewhere here, give myself a bit more room. And similar to what I've done for the bottom crystal, just going to move this up for the time being. And it's going to be a bit messy for now. Oh, by the way, I just had some news to share. I know I shared this news with the people that joined the Discord. Was recently monetized on YouTube. So yeah, thank you all for kind of watching my videos. As you know, it's good feedback that it's mostly positive feedback anyway. So that's good. And I do enjoy making these. I'm not planning on stopping or anything like that, even if I did get too much negative feedback. But yeah, it's been very good. Let's move this out of the way. Now this crystal, I want to put that down here and this one there, and that means I can bring this down. I can take this out a little bit and connect it like this. So again, I don't have a net label name on this, so I'm just going to make that really small. and change it. So I'll just add a 1 on the end. So that should be okay. I've got basically my 10 nanohenry inductor and the 10 microhenry inductor as well. So now I just need to connect up the RF pin. Right, so I'll leave this down here. So I mean, you can look at the application note here because that's the best really to get something working initially. So what I need is some capacitors. So I've got a capacitor, I need an inductor. So the capacitor value, 0 pico 8 farads. And on the output is 0.3 picofarads. Yep, come on, connect up. See, that goes to ground. And then I need this symbol. So that is a filter. Let's see if I can find a filter with 4 pins. Okay, so I've got some filters here. I don't really like the symbols inside it. And those don't really matter. I can probably just use one of these symbols. It is a low pass filter, so that is going to be something like that. That's fine. But I've got 4 connections to ground, so that's going to be these 2. So pins 2 and 4. And this is going to 5 pins. I might need to make this symbol. If you want to make this symbol, let's just go and make it. So save that, create edit symbols. So click that button over here, and then you basically get this screen. What I'm going to do is move my application note to the side. Now I have a library in here that I've created in the past, but if this is the first time you're creating a symbol, then you need to click File, New Library. So my library and new symbol in there. The symbol name, I'm just going to call that DLF 162500LT 5028A1. So no, not an existing symbol, and the code is FLT, or the reference designator is FLT. Press the OK button on that, and first thing that I need to do is bring in, so pin name, let's call it in as per the symbol. So what I'm basically doing is recreating this symbol over here. Got pin 1, pin 2, and then you got the ground labels as well. So pin number is 1, pin name is in. So put that on this side somewhere. And then if you want to change it to the right side, or the left side, I guess. So that's pin 3, and the name is out. I think the main thing I want to do is just make sure that it's equally spaced. So minus 8.89, minus 10.16, minus 8.89. So minus 10.16. So that's equally spaced. And then I want to have basically the connection pins for the ground. So that's pin name. I'll call it ground, pin 2 and pin 4. And then finally, I want to make a box. Okay, my grid isn't the best for this, so let's change the grid. It might have gone too fine. So basically I'm adding, let's change the grid again. So grid, let's go to 0.6350. And yep, now it seems to line up. Don't want any text. Is that a text box? I'm selecting the wrong box. Right. So basically put down a box, and then if you want to get like a KiCAD or KiCAD feel, basically fill with background color, click this box there, and you basically got it. That's it. And if you wanted to add some text in there, you can just put low pass filter or something like that if you want to. You don't have to. You will have a name on this part anyway, so it should be all right. So you got low pass filter there, and obviously they've got like these sine waves, I guess, if you want to call them. So if you wanted to add them, you need to change the grid, but you can add these if you want to. I just don't like messing around with the graphics on this stuff. So save that symbol. Now if I close this and go back to my schematic editor, make that full screen, and basically press the A button again and search for DLF1625. You can see I've got the symbol basically on the screen now. And then you got some output pin there, and this goes to ground. And connect that up to ground. Now I need an antenna. Just need to find one really. So we've got chip antennas. I'll just use this for the symbol. I'll need to find a part number for this, but yeah, just make sure I connect it up properly. So we got the antenna. Antenna shield. Oh, so I think what I need to do is connect this point to ground. Well, you got input there and passive there. Let's just put a normal one for now. What I'll do is when I find an antenna, find out how to connect it up, I'll change this symbol to match that. Now, obviously, this is the RF section, so I want to label that as RF MCU out. And then after the filter, let's just call that RF built. And let's call the RF antenna. Okay, so I've got the RF section done as well. Just gonna have a quick look at the application note again. Make sure I'm not missing anything important. So if you I don't know if you guys want to work with something like this, the application note for STM is AN5165. and it kind of gives you all the components and everything that you need to get like a basic circuit working for this microcontroller, which is STM32WB. Now just looking at basically the, not that one, so it's QFP and 48. I don't need to worry about all of this. I've obviously got the capacitors all connected up. I've got the VDD USB, got the RF, the analog power supply connected up as well. Now this has got an E-pad, pin 49. Okay, so that E-pad is connected up as well. That's fine. We've got basically these two components. We've got all of these components. We've got the pin 32 connected. Got a 32 megahertz crystal. They don't have loading capacitors. I've put them in because I need to do a bit more research on that, make sure that they're not needed. But I mean, I can have a pad there anyway, and not fit. Obviously, it's not ideal. Yeah, that should be all right. And then just looking at this side, you've got the NRST pin. So that's basically, that's pulled low to ground. No, that's pulled high to 3v3. And then that, I guess, connects to ground. So you pull that low and the diode goes in for forward conduction. And you've got a decoupling capacitor there as well. So let me sort out the reset pin construction. I think in terms of everything else is pretty much done. I've got the USB connected. That's right. I need to do the programming. So going back to here, I can go to sys, and basically I want to do debug serial wire. So that's P813. So that's SWDIO. Let me put this to the side. File, save project for the time being. Now I need 3 pins. So just looking at this, you've got, yeah, I've accidentally changed my net label, so 2.54. If shortcut for net labels is basically the N, and you can toggle between them. Anyway, so net label, I want, let's call it SW is fine, TIO. So that's 1 pin, and that goes on to P813. Then SW P814, so that's SWCLK. And then finally, I want SW, just gonna call it O. That is PB3, so got it in the wrong place. PB3. So connect that up. PA14 there, PA13 there. I'll need to find a connector that I can basically use to make this connection. Just make sure no the pins were activated when I did that. That's fine, leave that as it is. So I'm just gonna grab my curtains. I mean, it's coming together, isn't it? If you have any suggestions for me, just let me know. No problem, Turel. That's fine. What's the thank you for? Is it for the art of electronics? I think I get thanks a lot for that series. Obviously, I want to continue it, but it is getting. I mean, the final. So we're kind of near the end of. What's it called? Chapter 1 for auto electronics. Just got like 3 more questions to finish off, and then we can go into chapter 2, where we start working with like BJTs and stuff like that instead of just resistors and capacitors. So, you know, really hoping to build more circuits, really. So that's the main thing. Because the reason I started the series, I was like, you know, whatever circuits I get on the art of electronics, I want to build up. So you might have seen like the input protection video. That was from art of electronics. And I think there was another one as well. So obviously that was the diode protection. Then there was the timer circuit, the RC timer with the op amp on there. So that was quite good. Now going back to this, got the SDIO. Obviously I want to connect that up to a header. Now looking at my programmer that I bought recently, it's a 20-pin header on there. There must be some way of connecting to the microcontroller a little bit easier than a 20-way header. So what I'm talking about is ST-Link V2. Just looking at this. Let's get the data sheet for it. Looks like I've already downloaded it before. Okay, Mini. Yeah, I use Altium quite a lot, but for work, I use Altium more so than I use KiCAD, to be honest. Obviously, getting an Altium license is very difficult. It's quite an expensive software, so I think, you know, workplaces can justify it. But for something like YouTube, I can't really justify a license, to be honest. So KiCAD it is. I mean, KiCAD's pretty much does everything we need anyway. I know Altium does have, I think Altium has a better workflow. This is a bit weird in that, you know, you kind of put down your components, but you don't really have a footprint as of yet. Well, you do on some components, but yeah, it's a bit weird. Have you done any Bluetooth design, Mini, with STM processors? Yeah, I think that's the way to do it. I mean, just looking at this component for the STM32WB55, this schematic symbol is not great at all. I think, you know, something like this, whereas this complicated, I think should be separated out into like, you know, subcomponents, if it were, you know, where you get U1C, U1A, B, C. So we can just separate the RF sections, you can separate the switch mode power supply sections, things like that. And the schematic would just look so much neater than what it does at the moment. Hills Lab, did you say? Oh yeah, can't load YouTube at the moment, but maybe. I just want an antenna, really. I'll go look for it. I need to find this antenna, and I need to find a connector for the programming and debugging. Everything else. So I've got the NRST pin over here. I think that means I can bring this down a little bit. are you thinking to try out STM32 for RF design? And this is the first time I'm doing Bluetooth. So now I'm just following this. I guess what's it called? This application note, if I can really find it. So this STM5165 from STM, and it's RF hardware design. So you might want to have a look at that if you're planning to play around with this. I think I know what I'm gonna do. So let's find the STM processor for. Well, first of all, I want to find the pinout for this. So it's obviously not. Okay, yeah, I know quite a few people at work who have used NRF24s. But I've not really, because I mainly work with analog electronics. So I don't really do that much embedded hardware design. Well, because I work in aerospace engineering, and yeah, software is very difficult to implement because you need a lot of qualification. So documentation. So we've got the user manual here. Right. Yeah, so this is the cable that I have with my V2, ST-Link V2. And you've got the pin numbers here. So obviously most of them are not connected. What I do need is this one, so pin 7. Or what I do need, I need pin 7, pin 9. I think pin 13, pin 15, one of the ground pins, and I'm surprised 3v3 is not, oh there it is, 3v3 is there as well, so pin 1 and 2. What I might do is just use a 20 pin header for the time being, because this is going to be sort of a development board. Going back to the reference manual, you've got the, so that is 1 2 3 4, 1 2 3 4, so that's fine. And I think I'll make this like an edge connector or something, and I think that'll be okay. Yeah, it really is terrible. Now I've mainly worked with microchip processors for my previous job, and they had like a 6-pin connector where you use 5 pins, and yeah, that was a lot easier to work with. And this, I think I need to like maybe just make my own board or something, like an adapter board. I'm sure you can buy them, but buying PCBs nowadays is so easy. It's probably easier than buying a custom made adapter board for it. I'll pick it 5. I've got a KiCAD 3 on my desk, and it's missing its top cover. And I use this like maybe, I don't know, 9 years ago, 10 years ago, something like that. It still works, so it's not bad. It's held together with electrical tape. But yeah, like I had to resolder the connector a few times. But yeah, then when we finally went to production with that product I was working on, they bought on ICD 3 and then ICD 4, I think it was, which was, I think the programming was a little bit faster on that, which was good for them, obviously. So let's just connect this up. STM link v3. Is it this thing? Looks like you've got more connection options. I see. Right, back to this. So I need pin 7. And pin 7 is this one here. Yeah, it's bloody hard to change pin because I have to do this. So let's look for it. Come on. Why not? S33 mini. I'm guessing it's this one here, right? Is that a smaller connector or is it the same size connector on it? Ah, okay, it's a smaller pitch connector. I see. Fair enough. Let's get rid of that. 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 That's it. Okay. Pin 9. And then I want. Oh, okay. I think I got that wrong. SDIO. No. So clock is pin 9. That's fine. And I think it's this one. Trace pin 13. So pin 13. And I want the reset pin as well. I mean, that smaller connector is better. I think because you only need like 6 pins or something on this. I don't know why it's such a big connector on it. I mean, for a development board is fine. Like, you know, I can put this header in there because this board is going to be quite big anyway. Pin 15 is NRST. I'm not going to take that all the way to the other side. So SM. I'm going to change the alignment on this. If I can. Nope. I know there's a way to change how this aligns up, but we'll look at it later. Right, so put that down there. Okay, I mean, I've got the V2 already. So for this, I think it'll be okay for now. But yeah, if I start using because this is the first time I'm going to kind of use STM boards or STM microcontrollers. So let's see how it goes. If it doesn't really work out, then I'll change it around. Now I'm thinking what to do with ground here. I think I'll just connect all of them to ground. So pin 3. Pin 5. Pin 12. Pin 18. And pin 20. Oh, so did you make your own cable? I think that's what I need to do. So I mean, like getting a PCB and putting a socket on there and then converting it to a smaller socket or something is probably not that hard. Now the PCB design for that wouldn't take long at all, so that's what I might end up doing. And I've got some connectors anyway. Pin 4, pin 6 not connected, pin 8 is not connected, pin 10 is not connected, pin 14 not connected but has a note used by, I don't have that, I don't have the isolated version, so that's fine. Pin 16 is not connected, pin 17 is not connected, pin 19 is not connected, pin 11 is not connected. Right, I think I've got that right. I've got the NRST, the microcontroller reset. No, we need a decoupling capacitor, I believe, on this one. Or normally there is one anyway. So this is table 6 that we're looking at. We sorted out the inductor. We've got some part numbers from here as well, so that's good. I can update my bill of materials with that actually. And then I have a capacitor, pin note 1. And I might just use my standard one anyway. So I've got that. And where's the 10 nanohenry inductor? There we go. I'll leave them copied for now. Where's my electrical pin out? I need to go and find my bloody pin out again, but that's okay. Tag connect. Oh, I guess it's this thing. Oh, that is quite cool. Can you get the cable by itself? Oh, this thing. I mean, yeah, that's exactly what I was thinking of designing, to be honest. So yeah, that would be quite nice. Well, this PCB anyway. I mean, that connector is quite nice. Locks in. Should I noted down the page number? No, there's nothing to it, but just scroll through the whole thing so I can find the bloody thing. There we go. So that's the one I need. So let me make a note of that actually. STM32 WB55XX datasheet page 82 decoupling. Okay, so the reset pin, obviously that's not going to be on here. Let's see. So it's got an internal pull-up, recommended in ST protection. I'm not going to be using the reset pin. I don't think I've ever used it. So I just need a 100 nanofarad capacitor. Phil's lab made. Oh, okay. Yeah, I'll check it out. I mean, I'm going to make a video on this anyway, so it might end up quite similar to what he was doing, but we'll see. Phil's lab 127. I have seen his, I think I've seen his channel before. Right, and move that there. It's got an internal pull-up, so I don't think I need an external pull-up. All reset protects the device against parasitic resets. The user must ensure that the level on the can go below VL, so 0.3 low level, so that'll be fine. And so we can add a switch on this. Actually, I'm not, like just said, I'm not going to use this, so I'll just connect it up to here. That's fine. Now the next thing I needed was my IMU, which was this part number here. So let's see if that's available on KiCAD. List 2. So I mean, that looks quite similar. They're all quite similar. Let's see what the differences are. So let me load up my data sheet. Documents, channel. So DH. So all I'm looking for at the moment is ordering information. See what the differences are between the packages they've sent. If there are no differences, then I can obviously use it. Otherwise, I'll just check the pin out and just use it that way. That should be all right. Soldering information. Functionality. Package. Right, okay, I think I'll just have to check the pin out. So pin description. And go back to KiCAD. Or is it KiCAD? Who knows? Right. Put a symbol down. Okay, so we have, where's pin 1 on this? There we go. So pin 1, DE2. Oh, so it's not this one. It's going to be one of these. Pin 1 is SCL. Yep, that's fine. Pin 2 is chip select. Pin 3 is SDO. Yep, that's fine. Pin 4 is SDA. So I'll probably be using I2C for this. Pin 4, pin 5 is reset. Pin 5, yep. Pin 6 is ground. Looks like they've combined the ground here. Pin 7 is ground. Pin 8 is ground. Pin 9 is VDD. Yep. Pin 10 is VDD. Pin 11 and 12 is int 1, int 2. Okay, yeah, so I mean that part matches up, so I'll just use this. So let me put this down here. And obviously I'll need to look at the data sheet for this in more detail to make sure I'm using it correctly. I'll put a box around this. Right, so there should be minimum circuit requirements somewhere in the data sheet, hopefully. If not, I'll just do what I do with this, you know, in terms of standard, like just adding some decoupling. So the end goal for this, this is a product that I'm designing for someone. I can't really say the company name, but basically it's gonna go in a pedal, and it's got Bluetooth, and it's got an accelerometer. I might add a EEPROM in there, but it's going to at this point, it's just a dev board. So you know, and I'll be doing the coding and everything as well. So as soon as it's working, the plan is to shrink it down massively. So I will be getting rid of as much components as I don't need. So, you know, or just shrinking the board as much as possible. But first of all, I want to get something working. So for the end goal for this PCB is to have a working Bluetooth hardware and working kind of accelerometer hardware. Is it? I've never done it before, so yeah, we'll see. Is there drivers available on STM, or do you need to write your own and everything? You can have a look on here. Got RF, activate RF1. Yeah. I mean, there might be some drivers in there, but yeah, we'll see how it goes. I know I've worked with like USB a while back, and that was quite difficult. So I'm not expecting it to be easy. But yeah, I mean, I'll make some videos out of it. It'll be good learning. Okay. App to do what? Help you kind of debug stuff, or is it app to program it? I see. Okay. So kind of testing on the other end. Yeah, makes sense. I'll definitely need to get that. I'll check out the video. Thank you for that. Right, on this, so where's the electrical interface? Got the block diagram. I think I just need to look for it. Let's see what the descriptions are. So we've got, there should have been multiple pins, but we'll see. Let's connect that up to ground first. VDD. It seems like there's, here you can see the firmware part. Oh, if there's help available, then I think that will make my life a lot easier. Because I think something like this can take a lot of development time. Yeah, we'll do. I mean, I can't search for it now because obviously that's someone else's video and I don't want to stream it. But yeah, I'll have a search afterwards. I see. So do you write your own libraries or is there some of the source? Right, so that's the I squared C communication. Obviously I'll need to add in some resistors in here. So let's just put some placeholders in there for now and I'll set the values as TBD. Because I'll need to go through this data sheet in a bit more detail. That should have a 3v3 node on it, so yeah, let's connect that up. Okay, and for this one, I also want the same here. Right. I really don't like that. I might be able to put the resistors down here. Hello, can you still hear me? Hello? On my stream it should... Is there still no audio, or can you still hear me? I think the audio on my end is fine. I don't really have any viewers to check anyway. It's just you, Minnie. That's all we have. Wait. Ah, okay, cool. So it's telling me I need to change my audio stream rate anyway, so let me try that. So I don't really stream that often, so... General... Advanced... That might be a bit better, I don't know. We'll see. No, that's alright. I was just basically putting down these pull-up resistors on the I2C line and going through basically reading the datasheet for this LIS2DH port IC. I've changed the bitrate on it as well. It says audio stream current bitrate is lower than recommended bitrate. So I'm not really sure what's going on. So I've got a warning message as well. So it might not have been you. So stream, output, audio, video. It's, I don't know. As long as you can hear me, that's all right then. Right. Okay. So how do you? So chip select is fine. So what I want to do for that is PB7 maybe. If I need to use it for something else, then that's what I'll do. But oh, okay. So I've got, maybe this wasn't the best I2C line to use. Let's see where let's see where the other I2 is. C is. So that's up there. Well, one of them's up there. The other one's down there. Okay. Might just use PA0. Okay, let's disable this and go with this as a digital IO output, and then IMU NCS, and that is PA0. So that is not negative. Okay, let me get rid of the N on that. Okay, thanks for letting me know. Well, I'm just trying to work out, that is a good point. I'm just reading through this. So SPI idle mode. So I need to basically connect chip select up to 3v3 is what I need to do rather than chip select. So let me get rid of this. So I was thinking maybe chip select needs to go 1, but it doesn't need to be controlled because it's going to be 3v3 all the time anyway. So yeah, you're right. Just use some value resistor to pull that up to 3v3. Right, I'm not sure what other resistors I'm going to have. I'm definitely going to have 5K11 here. I'll see what the recommended values for the pull-up resistors are on this. And I'll try to basically use the same value for pull-ups there if I need to. Okay, so just basically let's stick to this for the time being. So I've got reset needs to connect to ground. So let's do that. Yeah, probably 5K1 from here is fine. Just thinking if I can, if these pull-ups are 10K, then I was thinking I'll just use a 10K. But yeah, that should be okay. So reset goes to ground. That goes to, that's 7, 8. I've not got it on the symbol. VDD, that's fine. Now interrupt 1 and 2, that I might need to put onto the microcontroller. I2C communication mode enabled. So pin 4, that's all fine. So what does pin 3 do? Oh, okay, so this is the address bit. Or I'm just gonna put this to ground. And where is the address? IMU slave address is 0B001100X Oh yes, so SDO can be used to modify if the SBA is connected to the voltage supply LSB is 1. So that's this one here. So that for me is going to be 00110000. And then I think the last bit is read or write. Right, so I've got the address there, that should be all right. So yeah, this is the one. So 0011, 3 zeros and a B. So okay, make sure the address is okay. And the last thing I want to do is make sure I don't need to pull up or anything on the interrupt lines. And just have a quick read on what the interrupt lines do. Push, pull output, force to ground. Okay. I'm not entirely sure I'll be using the interrupt line, but I know there's sometimes like if data is ready, it sends you a signal. So I might just leave it disconnected for the time being. But I'll have a read later. I don't want to go into too much detail here. These are all the internal registers. And I think I'm way past the interrupt. Oh, maybe I just got to it. If I can't find it in like a minute, I'll just do it again later. There we go. This is what I was looking for. 100 nanofarad. Oh, they recommend 2 capacitors on this and a 10 microfarad. Do you think a 10 microfarads needed for an IMU? I mean, I'm just gonna add one, but see what happens afterwards. Five and six is ground. Int 1 and 2. Let's see where I can connect them up. I think it's better to have the functionality and not need it, and then rather than just not have. Yeah, I think I'll just go do not fit on that line, and if I see any issues, I can add it on. So I'll just go do not populate, because I'm not tight for space on this board anyway, so I'd rather just the board works. But I think I've got more than enough capacitance on there, to be honest. So I don't need that. Interrupt. System wake up. External interrupt. PA1 and PA2. Last option. PA1 is 1, PA2 is 2. Okay, so that's that done. One of the bloody components I've been. Yeah, I saw that. I know it was. There's like a little side note somewhere. And when I was really going through this datasheet in more detail, it came up. I seem to remember PA9 for some reason, so let's try that as a search function. I mean, I might be completely off base here. I am off base. I think for something like this, sometimes ChatGPT can be good. So see if it, I mean, it might not be accurate. Oh, thanks for that. There we go. I think I found it. So I just asked ChatGPT. So this is a STM32WB55. So I asked ChatGPT what can wake the processor from deep sleep, and it said PA0. So I just did a quick search on PA0 and I got this as a search result. So PA0, PC12, PA2, all of these can wake the processor from deep sleep. Let me make page 38. I think it's good to have these notes because we're going to be searching for it all the time. PA0, PC13, PC12, PA2, PC5. And I've got PA0 open. There we go. So let me turn this one off. Right, okay. What was the next thing? Let's go back to my bomb. So I've got my USB-C connector, got the protection, got this part, got my regulator that I need to put to 3v3. I don't need bypass on it because I don't need low noise. I need to ground this thing. Right, enable, that's fine. Don't like that. Let's just put it there. Put a do not connect line on this. That's intentional. Now boot 0. I think that's PB0. Where's boot 0? Okay. I think it's such a common part. It's like so available wherever I look. It's just, yeah, I think most people end up using it. I think the other one I've used for kind of low noise applications was like TC1015. I think that was 100 milliamps, I think. This is 150 milliamps, I believe. I should be enough for this application. Got D plus there, so the plus and minus. MCP 1700. Have you used that before? It's a little bit higher power. That's good. Nice package. Yeah, I'll try to use it sometime if I need a little bit more power, I guess. So just got some LEDs for. I need to find a different LED anyway. That one's not good. Got this. Oh, that's right. So it was the battery charging. Do you know any circuits or ports that are good for charging a single cell LiPo? I've been doing a little bit of research and I've come up with like two part numbers. I think the first one was like LTC 4054, and then there was an alternative, I think BQ 29700, but none of them kind of have full functionality, and I don't want to go down the path of doing TP 4056. Yeah, I've seen TP 4056. I mean, I did a design with it on my channel previously as well. I've not seen the 24079. I'll have a look at that one. BQ24079. I mean, I might just use this. I mean, this is really simple part, and obviously I need to try and integrate it into my design somehow. But it doesn't do under voltage protection, which the other one did. It's because all my logins are on this one, and I can't be asked getting my passwords for everything else. Anyway, so this part 4054, yeah, it doesn't do cutout if you're under voltage. So that's the bad thing about it. Now the BQ, I think it was BQ, what was it, 29700. This was quite good as far as I remember. Ah, there we go. So I've looked at this part number before, and this has got everything I need. But again, it's got yeah, that's the one I'm just looking at as well. BQ 29700. Now the kind of some of the things in there, it's like it's for high. It is negative terminal. Sorry, what do you mean by that? Oh yes, yeah, similar to the TP4056. Yeah, it disconnects the negative terminal rather than the positive terminal. Okay. I mean, yeah, I just need to kind of. I might just do it on a separate board and then integrate it together afterwards, just to keep my options open. 2980. I'll have a look. BQ 2980. Nice. Okay, I mean, I'll have a look at this, and obviously I need to find a lot of components for this. Current sense resistor. Oh yeah, so you got this down here as well. Is that for toggling? Is that for, so you got more flexibility for the FETs over here? Because I know the other one, I think TP4056 uses the FET resistance to do the current limiting or current sensing. But basically we're saying the same thing, aren't we now? I'll have a look at this. Obviously, I'll need to find all the part numbers for this. But let me just make a note of it so I don't forget. Another thing I might need to do is get rid of my LDO and change it to a buck boost converter. Yeah, I think you got a lot more flexibility with the sense resistor, don't you? What else do I need to do on this? I think there's nothing for it but to do kind of... Yeah, the only problem is if I've got a single cell, basically that's going to power this microcontroller eventually. It's not really for this dev board, but eventually what I want is a single cell that powers the whole thing. So the single cell voltage, I think, goes from like 4.2 volts to maybe 3 volts. Now 3 volts is going to fall below. It might not. It might be okay. I might not need to regulate it at all. Maybe I just add in a buck boost converter that does 3.3 volts. So let's do that now. I think pretty much everything else is just done, really. I can't think of anything else that I need to add on this at the moment, except for the power LEDs, which I can do now. So I want to add in a 5-volt LED and a 3v3 LED as well. So let's put that down there. Get this resistor. I still need to find my LED as well, so like that's actually, I might actually put another LED on here as well. What did KiCAD do there? Can I show VBus? Yeah, so I've basically put it to this protection line or protection IC, and I've connected it up to here. Basically to the LDO, but I think I might change this later on. Just need to do a bit more reading on maybe boost converters and the charger IC, because if I'm going to use the charger IC, then this configuration is not going to work, because I would want the USB-C connector going to the charger IC rather than the regulator, and then the battery pack being converted, I don't know, to a stable 3.3 volts. I was looking for that actually. I couldn't find it. So I know normally on a processor that I've used before, there was a USB detect line, but on this, it's not showing me the options really. So I tried to find it when I did the USB. Yeah, it's just nothing there. I know there's sometimes a USB detect pin. Yeah, I do. I do want a USB data. Yeah, exactly. I don't know which pin to connect it to. Because normally it's just an option, isn't it? Or I mean, I'm not really familiar with these processors. It's normally USB detect. If not, I'll just do a search on the data sheet, see what it does. Because I'm sure it gives you an option over here somewhere to kind of select, you know, if you want it device only, which obviously this has got the device tick, which is fine. So it just, you know, brings up those two. You've got the basic parameters. You got the full speed and everything like that, but it doesn't show you anything else. Let's have a look on the data sheet. Might be a bit easier. Right, where is it? Yeah, no search basically. Hello, Bob. You all right? No, you comment on my videos quite a bit, so thank you. Appreciate the support. I've got VDD USB connected, but it just says to connect up to VDD. Which is the 3v3 line. So I mean, there's just basically the transceiver, the USB transceiver is always on. I know there's in the microcontroller I used before, there was a USB detect line as well, which you use to sense the basically USB cables plugged in. See if there's any information on VDUSB. So that's the electrical parameters. So if you're using USB, it just says to connect up to anything above 3 volts. Too many detects. I'll have a read later, see what happens with that one. I mean, that seems to be the recommendation at the moment, so I'll stick with that, and then if I need to change it, I'll change it later. If I'm just looking at kind of the hardware data as well, in the application notes, and I've made a folder for it. So application notes, RF hardware design. This is the kind of data sheet that I'm really following anyway. Datasheet, I mean the application note I'm following. I mean they probably don't even consider the USB, so they just connect it up to VDD USB because they don't have any other peripherals on this. They've got USB negative and minus. I think when in doubt, just go to I'm hoping there's a schematic in here somewhere, but if not, I'll have to have a read later. Let's see how it goes. So just let's go back to the schematic for the time being. We've got our USB connector, we've got the 5 volts, got the 3v3 converter in place now, got our power indicator LEDs. Right, so we've got these LEDs. I need to find the LEDs before I calculate the resistor values. Got all the components that we need for these internal switch mode power supply, so 10 nanohenries, 10 microhenries, and a 4.7 microfarad capacitor. Got a debugging LED on the microcontroller itself. Got our IMU connected to the I2C protocol or channel on this microcontroller. And on this side, we've obviously got the recommended components for the RF filter. This is the matching network, and then this is the low pass filter. Now both of these components are just from the datasheet and the application note from STM. Got our high speed oscillator, so we need to still find this part. We've got the low speed oscillator, so that's 32.768 kilohertz crystal, and all the components that we need for the various different VDD pins. So I don't have anything analog on this, so I'm not going to separate the analog VDD supply. And I think in terms of basically everything I need, I think it's all there. I just need to connect up the boot pin, which was on PH3. So find PH3 somewhere. So, okay, it's hidden here, which is good news, I guess. Because now I have to not route it properly. So let's see if I can actually get it out from here. That'll be a bit easier. So in terms of the boot, I think I'll need a switch. So is there a slide switch symbol anywhere in here? Otherwise, I'll just use this. I'm not entirely sure which way around this works in terms of, is it 0 to go to bootloader mode or 1 to go to bootloader mode? I'll need to do a bit of research on that. Make sure I get that connected up correctly. I think I'll just pull it up to 3v3. That seems to be quite common. That's a good shout. Well, that doesn't tell you anymore. Unless I'm blind. Might be possible. I'll have to, I think, because it's not in the data sheet, I think I'll need to go into the reference manual. Right, which one? 802 15.4. So it is one of these two. Low energy. I can't see the difference between these two over here, but yeah, first one, I'll take your word for it, Mini. There we go. Through different CPU1 boot modes can be selected through boot 0 pin and boot 1 pin. The values on boot 0 are latched after a reset is up to the user to provide the correct value. So resampled when exiting standby mode. So is that to kind of to be in run mode? You basically go to 0. That's fine. Let's just have a quick read. It doesn't make it easy, does it? Main flash system memory. Embedded as system array selected as boot area. I'll just have a look at some reference designs to make sure I get it correct, because thank you for that, Mini. I just had a quick read. I think I'd really need to check out these Phil's lab videos, because it seems like it's really good. From what I can tell, I think I need to ground it and add a pull-up switch for kind of 3v3. So let me get a push switch. Let me get a pull down resistor. And copy that. You need to pull down and a 100 nanofarad capacitor as well. Okay. we need to pull down, and 100 nanofarad capacitor. Yeah. I think the last thing I need to do is just basically, I'm not going to do that right now, but find these LEDs. I'll need to design a symbol for this. I think I'll make an edge connector for now. And find the two crystals. Can you say, I'm not sure what you mean, pulling up other side? Do you mean like this side? So you got 3v3, 10k. Oh, so you've got a pull up, not a pull down resistor. So 3v3, then 10k pull up. Move it to after the switch. Does it need to be pulled up or pulled down? It looks fine. It is pulled down. I was just talking about how it would look better. Functionality is correct. Right. I think I'm just gonna, when you're not just trying to read off text, I'm not too sure. So obviously this is gonna work, but then this is putting the switch directly onto this. So this creates an RC filter, and maybe this is what you mean. Put this resistor this side. Yeah, I'll check that video. No, it's fine. Don't worry about it. I think you've been quite helpful to me actually. I'll check it out. I mean, this looks like both of these will look like it works. Yeah, this will pull it up. I mean, looking at the potential divider that we've got here with the 3v3, this is going to be well above. So let's just do it. So equals this times 10,000, 10,220. Yeah, it's going to be fine. The way it is, I mean, I've just moved this. I think this is what you meant. So move this resistor to this side. Yeah. Okay. Yeah. Thanks for that. So I mean, I don't think I have got anything else left to do on this, except for obviously doing a bit of research, going through that BQ29080 pin or 2980 IC. I might just go back to the art of electronics for a bit. I've got a bit of time before I need to go. Thank you so much for your help, Minnie. It's very helpful. So make sure I save that. It is very simple. The only problem with the LT4054, it doesn't have like over discharge protection. I'm not particularly worried about overcharge protection, because I don't think I'll go into that. I don't think I'll go into that situation, but yeah. And then if I do go through the battery route, then I'll need to change the kind of the configuration of what I've got at the moment, because I will not be able to have this set up. I think what I will have is that the USB-C connector will go to the charger IC. Then the charger IC will go to the battery. The battery will then go to maybe a switch mode power supply, maybe a buck boost converter. So yeah, I think I can put a buck boost converter in. That's not a problem. I don't have too many parts on this. It's just, yeah, just sorting out, making sure it works. As an alternative, maybe I can just have this in here just to get something working first, trying out the kind of the hardware, the coding and everything like that for Bluetooth, because I know, like you said, it's going to be quite complicated to implement. Yeah, should be good. I'll just need to do a bit of reading on that. So the part that I selected initially was LTC4054. I'm a bit too minded on that, really. What else? I think that's it. I've got everything I need covered. No, I think the part you said with the resistor, I think that's better. I don't like using the MOSFET resistance as current sense. So I'm gonna try and implement this, but what I'll do is I'll do it as a separate little system on the side, so that I can test both things at the same time. So I can test this setup and I can test the battery charging setup. And then obviously if it all works, then I can combine them at a later date, because one of the main things I need to do over here is shrink this board down to as small as I can get it really afterwards. So I'm going to be trying to get rid of as many capacitors as I can, which might pose some problems, but we'll see. I might go 2 layers, double-sided assembly as well, which I know will increase cost, but again, I can shrink the board down and move a lot of the capacitors onto the underside of the microcontroller. Ideally, what I want is this to be kind of like 1 centimeter like height in terms for the board, which will be difficult. I mean, I don't know. I need to find an antenna. That's a good point, actually. It's one of the things I was going to do today. So let's see if there's a recommendation in the application note. Last time I checked, I don't think there was. Oh, I want to go with the chip antenna. I just think that's going to be a bit easier. So in these laws, just have the connectors and the recommendation. There doesn't seem to be any recommended chip antennas on this application note. I mean, I don't. So check out Phil's video. Yeah, I'll have a look. Did he use the chip antenna as well? Or did he go for a very similar thing to this where he just had a connector? Look at what they use. You can check out the nuclear boards based on this MCU. That's a good shout. I'll see what they went for. STM32 WB. I'm not sure if this is the right thing. Normally they would provide kind of the files. So we got the bill of materials, board schematic, CO2. Oh, let's go with this one. Have they gone for a PCB antenna? Oh, they have, yes. So basically, yeah, got two options, I guess. Can't see the connector anywhere, but I'm sure. There will be quite a few chip antennas. I just need to make sure I get. I mean, I can do a UFL connector. It's just I think that might make my board size a little bit smaller anyway. But I'll need to see if I do go with an external TI. They do. So I've used these processors before. Oh, they're just PCB design, I guess. PCB designed antennas, chip antennas. There we go. Thanks, Bob. Yeah, I just need a part number, really. That's all. Let's see if I can find one. I mean, this application is quite good to have. Let me just save that. I don't think there's options for chip antenna. Mechanical style. There we go. There we go. There's quite a few here. Quite a few, yeah, only like 7,000, I guess. Oh, okay, so did he go for a connector? Because this is 50 ohms. I think he'll be fine. Just need to make sure that the frequency range is right. I know 2.449. Wi-Fi. There we go. Now we're getting some part numbers. Thank you, Arvin. So I'm just looking at this. I mean, I know it said Bluetooth on. No mention of it. I think that's it. Might use this one. I'll have a look at some reference designs if I can find any. And let me just save this part number. So before I go, the thing I was working on right when I started this stream was Art of Electronics. So yeah, with reference design, I mean, like if there's any development boards with the chip antenna that, you know, I know it's gonna work. So I like, for example, just had a quick look at the nuclear boards. And obviously they're kind of made to just, you know, you buy them and you can use them straight away. Or in the data sheet, they might have some recommended part numbers or something like that. So you can just, you know, basically borrow as much of the design as I can. So there's less time searching and then less time wondering if there's something wrong with that component. that might make it not work. I've not read through all of it. This is one of the reasons why I'm kind of doing, well, this is the main reason why I started my channel. So it was to kind of motivate myself to do art of electronics. And another reason, because I did my university maybe 12 years ago now, 13 years ago. And I was reading art of electronics at the time. And obviously it's quite difficult. The questions are not easy. And it was basically, you come up with a solution, you think, is that right? And there's no solution anywhere. It doesn't give you an answer. So I just wanted to make something that if someone else is reading these and basically reading this art of electronics book, then thanks. I am 30. I'm going to be 33 soon. So yeah, I'm not that old, I guess. Hopefully I don't sound 12. And then if there was some reference answers or something, it would be fantastic. Like at the moment, when I upload my videos, I sometimes think, oh, hopefully this is right. But yeah, it's like, I think most of the time it is correct. And then I get some good feedback sometimes saying, oh, maybe you could have done this better or something. And then we kind of all learn from it really. So that's good. And I mean, Art of Electronics it's a good book. It's like the way it's worded is quite nice. But yeah, so I was working on exercise 1.41 for my next video. And in this exercise, obviously, we need to design an RC filter. So there's so many questions. Oh, chapter 2. So I think chapter 1 goes up to exercise 1.45. So yeah, three or four more questions to go, and then I'll be on chapter 2. And then obviously we'll start looking at BJTs and things like that. So that'll be quite cool. Yeah, I can't wait to get to that part, because one of the other things I wanted to do was kind of just build up the circuit. So I bought load of components. So I bought quite a few op amps and things like that. Yeah, so I can't wait to build up the circuits that come up in like chapter 2. I think the circuits will be a little bit more exciting. I mean, I built up 3 circuits in chapter 1. There's that input protection and the RC timer and things like that. We had those oscilloscopes as well, Bob. When I went to university, actually, they like second year of uni, they replaced all the old oscilloscopes with like really nice Rode and Schwartz ones. But before that, they were like CRT ones, which I know you can play Doom on them, so you can't go wrong with that. So anyway, this exercise, we need to design a RC filter. I think it's a high pass RC filter, because the attenuation at the higher frequencies is 0. The gain at the higher frequencies is 1. And the gain at like DC or 0 hertz is 50. So just basically going through this exercise, right, putting the slides together. I mean, if you just look at this response, it's quite easy to tell that, yeah, you got at DC, you basically got components. You've just got resistive components, basically. So you can set up a potential divider. And basically calculate the potential divider to give you the gain that you need at DC. So in this case, that's 0.5. So you're just going to have a potential divider with, 10K, let's say, for example, so equal value resistors. And then you can see that it's a high pass filter, so obviously I already spoke about that. But then what you're doing is just combining these two circuits. I don't have any oscilloscopes in my house. I've just got a picoscope 2205. CC antenna DKRD. Yeah, thanks Bob, I'll check that out. I mean, I don't really need to speak about auto electronics anyway. So let's have a look. CC, no, DKRD. Picoscopes are really neat, right? You know, they don't take a lot of space, and for quite a few applications they're okay. Obviously, if you want to do anything very in depth, then they're just not gonna cut it. But yeah, for everything I needed to do so far, it's been okay. What is going on here? So we've got design files. So it's just reference designs, isn't it? Quite a few of them as well. And then loads of chip antennas. W3013. Alright, so this doesn't really tell you what it's being used for. I think I'll need to go through the schematic in a bit more detail. Not that there's much detail there. Yes, I have, but very little. I've used some Xilinx boards before, and then very recently I was using RTX A7, but it was like a small project that wasn't that very complicated. So yeah, I wouldn't say I'm confident with them, if that makes sense. Right, what we need to do, I think I'll call it a day for today. I'll get that video recorded tonight, that'll be good. When I was in uni, I really enjoyed VHDL. I would like to do it again, but because I'm so far into my career, It's like there's not many companies who will take on a person who needs to like have a bit of a learning curve. So it's difficult, and it's not like my company is going to use FPGAs anytime soon. But yeah, I would like to learn as well, but very limited opportunity for me at the moment, to be honest. I guess I can do it through like my YouTube channel. But yeah, that's the I think another reason I guess I started my YouTube channel is trying to do stuff like this. Yeah, that's it. Because they obviously they gotta train up people. So you kind of get it from there. So if they can find someone who's already trained up, then yeah, I mean, unless you're really, really good, they might take you on. You never know. Or you ask for very low salary. The problem is I can't really ask for a low salary. So yeah, that's it. It is what it is. Okay. Yeah, thank you all for what area are you in at work? What do you mean by area? As in like what section? So I'll just tell you about my work, I guess. Sales manager, yeah. I would be a terrible sales manager. I think I'm way too honest. Um, yeah, I mainly work with analog electronics. So my job is aerospace, or is in the aerospace segment. So we kind of yeah mainly analog electronics, op amps and kind of like compensation circuits, high accuracy compensation circuits, and things like that. And then we do a bit of oh well, I do a bit of embedded hardware as well, but not as much as I would like. So yeah, it's a bit of everything, but mainly analog electronics in aerospace market. So we kind of mainly qualify to like DO 160G. So yeah, lots of stringent requirements, lots of documentation. Yeah, lots of processes to follow and things like that. But yeah, and I think the design work is probably like maybe 20% of my job, whereas documentation is probably a majority of my job, basically. Oh, pretty much. Anyone. Because I recently bought RTX A7, and that was, I think it was 50 quid, 80 quid, something like that. It's not that much if you really want to learn. I would, depends on the aerospace industry. I would recommend, if you enjoy design work, I would say be careful what aerospace company you join, because aerospace doesn't really move at all, really. They don't like change. So the design work can be quite limited. So if you actually got into electronics because you want to design stuff like this, you want to do some actual design work and experiment with different designs and things like that, that's very difficult in the aerospace industry, because obviously everything needs to be qualified. Like the qualification programs are quite long-winded, they take a lot of time, so you can't just make design changes all the time. So yeah, it can be, it's a, for me, it's like, I feel proud to work in that industry, and that when I see it, when I sit in a plane or something like that. But other than that, I think, in terms of electronics, I'd rather be doing something else. I'd rather be in like a startup, which was my first job, where I was just, designing a product from scratch. And that kind of experience, I think you don't get anywhere else. Obviously, you got to do longer hours and things like that as well. So I think that's really good, because if you're doing things from scratch, you get to learn so much more. It depends on you, obviously, how much you enjoy electronics. You certainly do, yeah. You need to be, I guess, long hours, need, be aware of the risks of startups, but then you can progress your career a lot faster, especially if the startup, takes off and you're at the kind of the start of it. You'll move up quite quickly, but there's obviously that high risk. Yeah, there's long working hours to make that product work. Yeah, it's a lot of, I mean, yeah, it's not easy. Whereas aerospace, I think, it's quite laid back. It's quite slow. It's a very well established industry. So yeah, you just gotta go with it. But then you can get, well, I guess move up to like senior electronic engineer roles, things like that. Kind of, not everyone needs to be management. I hate that. I know loads of people try to say, oh yeah, you got to be a manager, but you can go into like becoming senior electronic engineers and things like that quite quickly, and then maybe going up to, principal or whatever that might present itself. But if you know the technology from scratch, because obviously you've been involved in the design work, you can provide that feedback. Yeah, not everyone needs to be a manager. Not like you said, not everyone's cut out to be a manager. But I think some of the experienced guys can feedback a lot of good, useful information, I guess, experience back to, junior engineers. For me, like, I think I'm fairly certain I want to stay technical side. So for the rest of my career, which is, still 35 years to go, I want to stay on the technical side as much as I can. But then we'll see how all of this does. Anyways, guys, I'm gonna call it a day here. Grab myself a beer and just enjoy the evening. Thank you for joining the stream. I don't know, I shared with some of you guys before, but yeah, I was recently reached the milestones on my channel to get monetized. Not fully yet, but yeah, just like the first step where I can actually, yeah, I haven't earned anything yet, but yeah, let's see. I think it's just like you can do thanks and stuff, some bullshit like that. But yeah, yeah, thank you for joining today. I'll try to do more streams because it is quite fun. And yeah, this circuit here on the screen, I'll make a video on it, and yeah, I'll get that manufactured and we'll see how it works. It really is. I think it's so saturated. There's so many people doing different things. I think this kind of auto electronics niche that I found is quite useful, but I haven't found anyone else do it yet. But I don't know, there might be other people doing it. Who knows? Whereas like embedded hardware design, there's so many people who are doing this sort of stuff. Like circuits like this is just so many. I don't really have a website. I do want to make one. That would be good because I would love to have like written up answers for Art of Electronics on my website. I do have a Discord, but it's only like 6 people on it, and it's not very active. But yeah, if you do want to join the Discord, you can. Depends if you enjoy. There's people in there who kind of do talk a little bit, but it's not that active. No, I already do have a Discord channel. There's links in my videos if you want to join. let's see if I can show you. It is there's links on my videos, so if you want to go see it, you can do. I'll just show you to a video basically. Contents, if it loads up. Let's look at this one. So on here there should be, yeah, there's links. Like if you look at my latest video on series and parallel resistors formula, yeah, you can basically go through it and join the channel if you want. It's gotta warn you, it's not very active, but maybe eventually we can build up a nice community. So yeah, that would be good. Oh, thanks for joining, Winnie. Other than that, I actually I got monetized recently. I haven't earned any money, but yeah, just thought I'd share with you guys because it's, you know, for me it's a milestone. It made me quite happy. Yeah, thanks, Minnie. That would be good. I don't know what we can talk about. I mean, like I've said to guys, you know, if you want any help with anything, you know, at work or whatever, just drop it on the Discord and we can talk about it. If you're having problems with designs, we can look at that, because together I think it'll be quite good. Oh, it's not even been 1 penny yet. I don't know where to check. Where can I check? I don't want to show too much away on this. I don't know where to check, to be honest. But yeah, it's not even been a penny yet. That's fine. It's not really about the money, to be honest. It's just, you know, I mainly want to do the Art of Electronics book for starters, and then we'll see. Yeah, I'll make sure I'll buy you like 1/100th of a beer. Are you guys in the UK or you're dollars, so you might be America or Australia, who knows? Yep, there we go. I'm in the UK, so yeah. All right, guys. Well, thanks for joining today. I better go now. So I'm a cheap club soda day. Nice. I think they've bumped the prices up for soda as well. Have a good evening. Morning on your side, isn't it? Afternoon, I don't know. All right. Thank you guys for joining, and I'll see you later. Yeah, I'm gonna release that video that I was showing, and yeah, thanks for your comments as well, Bob. I know you always comment on my videos, so I appreciate the support. Thanks a lot, and I'll see you next time.